There we go. Hello and welcome. Today we're going to have a look at some pull requests at the Bicep repository. And if we have time at the end, I'll show you something new I've been working with. Until then, I'm just going to see if I can clean up my working area here before we get started. So today's actually my first day of vacation, and it's been a great vacation so far, but the coding I've done the last few days have been a little bit messy. I haven't had time to be as structured as I like to be. So I have files lying around a little bit here and there and almost everywhere. So I'm just gonna try to see if I can commit the gist of it here before we get started. Let's see. Wonder if I can lose this animation. I think it's yeah, just taxing on my CPU somewhere. I'll just give it a few seconds to get these files out of the way and we can get started. I think I'll have to find some other backdrop for my starting soon because my poor CPU is burning. Let's keep this file. This one. So not sure if we have any. It says 3 viewers. So say hello and tell me where you're from. What are you doing in the chat while we are getting started? Let's see. This one, yeah, I'll try that one too. Here we go. That should be everything. Alright. There we go. And now we're back. Perfect. Let's get things on my screen. There we go. And we should have a little switch button here somewhere. There we go. Yeah, looking good. All right, let's get started. So first off, I think we have 2 pull requests in the Bicep repo. So I'm going to go through this and do a quick code review. I think we'll start with this one because I think it's the smallest. So this should fix 157. Let's read that to start with. Oh, and I think we need some music. Let's get some music going. Yep, cool. Let's see if we have that. Yep, there we go. So when using get Bicep API reference and the type switch, I tend to get the error below since not all API versions with types available have the docs up to date. Yeah, that's a problem. So the thing with this command, which is kind of handy, let's bring it up in a new console and just see what it does. So I should be able to do this thingy, but I think we can use a version that actually is documented. Yeah, I don't know which version is documented. Let's try this one. So here's the problem. If we do this, this is an actual version of the hub route table, but yeah, so that didn't work because the version exists, but it's not not documented. But if we do the resource provider of Microsoft Network and do resource virtual hubs / hub route tables like that, it should maybe it's like this. Sorry. Hub routes. There we go. So if I do it this way, it should bring up my default browser. Somewhere, maybe. There we go. And take me to the API documentation for the latest version of the hub route table resource. So as we can see here in the documentation, 2020-07-01 is the latest one that is in the documentation, but there are later ones actually available. So if I do it this way, it works. If I do it this way and just do it like the exact way I type in Bicep, that will throw an error, as you can see. So let's go back to the pull requests. Here we go. Or the issue, actually. So Stefan wants a -latest switch that will take this, and if it isn't available, it will get whatever is the latest. Yeah, makes sense. Oh, cool, we got a Unitist comment. Good start. Let's look at the files changed. So this is some documentation. Looks good. Add an example. Okay, let's go down to code. These doesn't line up anymore, but I don't think we need to care about that. Extra space, nothing to really care about. Just the same. That's the same. This looks good. And we added a new switch called latest to the type string. Yep. looking good so far. So if is null or empty type child and latest is present, then we do URL equals space URL type resource provider type resource. So we're splitting this at the @ sign and then at the slash and take the first. The month, which is the second. And the API version is the same, but we don't split it at the slash. So this is interesting. So this will split the string in two, and then we will split each string on slash. But since the first string might have a slash and the second one won't. That's interesting. Let's look how that actually works in real world. So let's say we have this string. Dollar type equals this thingy. And then we do this. Let's see what we get back. So here, this should just give us the version and the string, right? So there's two strings, and then we split all of those strings with a slash, meaning that we split these into 3 ones. All right, I guess that makes sense. And then we take the second one. So we take this one, and that will be the type resource, and the type API version will be the second value of these two, which will be this one. Yeah, I can live with that. So if we don't have a type child and latest is present, do we get type child here somewhere? Actually, I don't think I'm gonna check out this on my computer. So let's go to this place and do larger text and say GitHub PR, I think it is, checkout, and this is 193. Here we go, and let's read this in code instead. So where were we? There were we. So source public get Bicep API reference. Source public get Bicep API reference. I wonder if we can see the changes in here. I think so. So if we compare this with main, that didn't work. I have a bunch of untraced stuff in here. Ah, it's working. Here we go. So we're looking at. Awesome. A lot easier to read. And we can take away that one and make this a little bit bigger, I think. Here we go. Excuse me. So here we see, yeah, so if we split this on slash and we get 3, then we do a type child, otherwise it's null. I think there might be instances where there are actually more than 3, but let's leave that to another day. So if list is present, we'll just build, and we don't have type child, we build our URL like this. Otherwise, if type child isn't existing and we don't use latest, we'll build it like this with an API version. Makes sense. And if latest is present and we have a type child, then we'll build like that. And otherwise we don't have latest, so then we wanted a type API and the child. Yeah, looking good. And then we change something here. Use latest parameter to open list. Awesome. All right. Excuse me. This looks good, and I think there was another file. That's just the XML. I'm just gonna assume that looks good because it should be automated. Let's just go through it and make sure nothing looks really weird. Good. Looks good to me. Approve. Submit. And Stefan will have to merge that himself when he's done. Next time is the Bicep parameter file. This is a bit more interesting, actually. So we fix one and close another. I'm not too sure what's the difference. And then we added ignore diagnostic switch in new Bicep parameter file. No need to output build warnings when working with parameter files. Yeah, that probably makes sense. Oh yeah, so this is a tricky one. We have this new command called update Bicep parameter file. It basically looks, so the point of it is that if I have a Bicep file and then I generate a parameter file for that template, and then I update my Bicep file by adding or removing parameters, my parameter file won't be valid anymore. So we built this update Bicep parameter file, which will update the parameter file. However, if you have a parameter file with, let's say, all parameters, and then you run update Bicep parameter file and say only use to update the required ones, one might expect that we update the ones that are required, but in this case we will actually only keep the ones that are required, which maybe isn't what one would expect. So he has fixed that, and now if you do parameters all parameters will be updated. If you do parameters required, only required parameters will be updated, but all other parameters should be kept as long as they are still in the Bicep. Makes sense? And then implement update bicep parameter file. Yeah, so this is the original, and Jens did build this and implemented most of it. So let's have a look. We have number 192, so let's do GitHub PR checkout 192. You're all awfully quiet today. Say hello and let me know you're there. Let this load a bit. We should do compare with main, I guess. Let my computer work for a little while. Hello, Bjornben. Welcome and nice having you here. 2 files changed. So the new bicep parameter file. Alright, so it's always using ignore diagnostic. This will just silence the warning and error messages saying that your template is good or not that good or not working or something. There's an extra space in here. That triggers my OCD. Not something for this PR though, but it apparently was here before. I'll have to live with that. Alright, and then we have the update bicep parameter file. Let's remove this so we can get a bit more screen state. We have some comments making it easier to find our way in the code. Try find a matching bicep template for the provided parameter file based on this file name. Yeah. So first we will, so if we don't have, so you can run this without just giving us a parameter file and not giving the actual bicep file. If we don't get that, we will try to guess the bicep file. If we can't guess it, we'll just write an error saying we can't find the file. Makes sense. And if we supply the bicep file, we will test that it exists. Here's a bunch of new code. So what did we do before? We did bicep file name, new bicep parameter file. Yeah, so we generated the new file and we generated the old file, or we imported the old file, and I think we converted them both to ordered hash tables. And then we just loop through them and make sure to merge whatever is in both. Yep, let's look at this new approach. So, parameter. I'll try to fix that. Let's see if I can do the Oh, okay, cool. Import the old parameter file and convert it to an ordered hash table. Yep, old parameters file, get content path, convert from JSON, convert to hash table ordered. Makes sense. So then we have the old parameter files, and then we generate a temporary bicep parameter file with all the parameters. So bicep file name is get item and get the base name, and create a new bicep parameter file, give it the path of this bicep file path, and output that to a temp path. If I remember correctly, we create a temp path up here. Yep, that's just the temp path. Cool. We do all parameters, and then all parameters file path is the temp path plus the bicep file name.parameters.json. Makes sense. Convert all the parameters file to order hash table. Oh yeah, because this one outputs a file, so then we have to import the file again. Yep. And then we remove any deleted parameters from the old parameter file. So we have an old parameter array, and then we say old parameter type dot parameters dot keys for each old parameter array plus equal to underscore. Yeah, so the problem with this approach is that every time we do this, the old parameter array will actually be stored, and then we will create a new old parameter array, which is one item longer than the old one. And then we will copy the whole old parameter array from the old array to the new array, and then we will add $_ to the last item. So if old parameter array contains one value, we'll create a new array that contains two values and is empty, and then we will copy the first value to the first value of the new array, and then we'll do the $_ to the second. And then we will take this one and we will put it apart, and then we will create a new one which has three values, and we'll take these two values and copy them into here, and then we'll take a third one, and then we'll take that one and copy it here, and then create a new one with four values, and then copy these three values to the first three ones, and then we'll add $_, and then we'll take this one and copy it here. You get the point. So I'm not really a fan of doing this. For this approach, it probably won't be that many parameters, so it doesn't matter technically, but I would like to see something like this instead. Let's say the array equals, and then for each object I'll just return $_. So if I do it like this, this will be more performant because we will only create one array once. Not super important in this, in this specific scenario, but yeah, I think we'll let it go for today. I wonder if this, so these ordered hash tables are a bit wonky. I'll show you what I mean. So if I have an ordered hash table, let's save it somewhere. $OH order hash table equals ordered, and a hash table, and I say like 1 equals 1, 2 equals 2. There we go. So now I have an ordered hash table. Problem is that if I do like oh.keys, so I think that will return an actual object of some kind. Let's do get type on it. Yeah, so that returns an ordered dictionary key value collection. So if I want an array of strings, I need to do something about that. And sorry for the sums from my share. I wonder if I have a get enumerator. We do. But that was an enumerator. So I wonder if I can do $list equals this, and I'll cast list as string array list. First one dot get type. So that's a string, and that should be. Didn't work either. There has to be a reasonable way to do something about these. String, I don't think we have that, but yep. This is interesting. So what if we get members on that one? Yeah, if you pipe it somewhere, it contains the string, obviously. So then we'll do a get member dash input object, and we'll get this enumerator object, and it has a key and a value. Ah, right. So we should probably dot value. That didn't have a value. Let's do like this. So it doesn't have a value, but it has a key, I guess. Entry has nothing. This is frustrating. Alright. Yeah, I don't think we have a perfect way to work with these dictionary entry thingies. Maybe if I do ordered hash table dot get enumerator dot key. Did it give me anything? Dot name. There we go. Take the first one and get the type. That's a string. Okay, so that was a bit of a tangent, but this should actually give us all the keys. Let's try that. All parameter array equals $. All parameter. Oh, I'm not even sure. Let's leave it. But I think we can do this way. So get enumerator.name should be the fastest way to actually get the names. But else it's milliseconds, so it doesn't really matter. I just like to dive into these kind of things and explore and see what happens. I learn something new every time. So for each item in all parameter array, if all parameter array contains the item, so if it's no longer part of the Bicep template, then we'll remove it. Makes sense. So now we removed all the parameters that's not there. Then we generate a new temporary Bicep parameter file if the parameter is set to required. So if we only do the required, we do a new parameter file into the temp path, and we'll call that parameters. Cool. And then we calculate the name of that, and we convert the new to a hash table. So now we have a new parameters file that is a hash table, and we have a old parameters file that contains all the old parameters that are still valid. Cool. And then with the new parameters file, yep. So we do the same here and say the parameter array here. And then for each new parameter, if makes sense. So if the old parameters file doesn't contain the item in the new one, we add it to the old one. And we'll say value equals, and then do the default value of the one here. Make sure it makes sense. And then we convert to JSON. Cool. I think that looks good, except for the one spelling mistake that we had somewhere. I think we can save that, and I think I can commit stuff to this. So the Bicep parameter file, this one, and we have the parameter, and I can stage that. Good. Fix spelling. And we should be able to push that to the pull requests. And if we update this, there should be Did Stefan fix something, or did I? Oh, no. Sorry. There's my fixed spelling, and that should only be the one parameter. Awesome. Then these checks will run and will probably be good. And then we'll review. Looking good. Approve. Whatever. There we go. All pull requests reviewed. And that should be working. So while we're waiting for that, well, actually, we don't need to wait for it. Let's just close it down and go look at something else. So let's do git checkout Bicep net. So this is kind of exciting, I think. We have a problem. So if I go back here and I get module, you can see that I have my Bicep module installed. This is the 1.5.0, so this is the latest released one right now. And then I do import module like ac.accounts, I think it's called. see if I can remember where we got this error. So that worked. Connect AC account. And we get the sign in. I'm gonna do that off screen. There we go. You get a lot of thingies, and then I'm signed into my demo tenant. I wonder where we got the... So I think it was if I do a new deployment. I wonder, like, let's get module ac.resources, I think it was. Yeah. So let's import that, ac.resources. So that's the problem I was looking for. The problem here is that ac.resources depends on some of the same DLLs that Bicep uses. So when I have the Bicep module loaded, I can't load the AC resources module. And that's a bit of a problem, because when I work with Bicep, I generate templates. And when I've generated those templates, I want to deploy them, often using the ac.resources module. So that's a problem. And if I look at this thingy, you can see that we have like these Microsoft extension .primitives and stuff. I think it's a few of these that are colliding. And also, Bicep is using a newer version of Newtonsoft.json than what is baked into PowerShell. So every time we build these packages or assets, we actually do this little hack where we hack. So we're actually doing a search and replace for this thingy, and we're going to replace whatever version they're using today with 1203, because that's the one in PowerShell 7. Because if we import a module that uses a newer version of Newtonsoft.json than what PowerShell is using, and since PowerShell is running in one process, all the DLLs are loaded into the same context, and that means we can't have two versions of the same assembly or same DLL loaded at the same time. Major annoyance. So far, we've been able to work with it like this, but in the latest version of Bicep, they took in some new DLLs which were also used by the AC PowerShell module, and that really was a problem. So I've been studying a bit, and I found this blog post somewhere here. Don't have it up right now. See if I can find it. I think I had it in one of my browser windows. Maybe. Yeah. So, oh, this is gonna be bright. Sun goggles on. Here we go. So this blog post talks about this exact problem and a few ways to solve it. So we've been looking at solving that, and for that I have created a new module that I hope we will be able to take dependency on in the near future. So let's look at that for the first time. Let's see if we can, let's do it in here so I know where we are. So let's go to GitHub Bicep.net. Here we are. And I thought we'll try to create a Git repository out of this and maybe see if we can get this published. So the whole new solution, it's still a bit of work in progress, but it has this Bicep.net.core, which is a PowerShell module targeting .NET Core, or actually .NET 5. And that's why it's called Core. Sorry. This one is the engine part, or the core functionality, and this is the PowerShell module which targets .NET Core. And then I take these and I build it together, and this is the confusing part because I call them Bicep and Core, and Core here is the PowerShell module targeting .NET Core, and Bicep here is the Bicep assemblies and my wrapper. So if we look at this, Bicep.net.core is a PowerShell project, or sorry, a C# project, and it has dependencies on the Bicep core and the Bicep decompiler projects. So I rely on the Bicep source code being downloaded to this temporary folder, and then I have a small wrapper. So I have a Bicep wrapper. This is just a static string that returns the assembly version. So this I can use to figure out which version of Bicep I use this with. And then I have a build and decompile method. So here I've just done a public PowerShell class. This means that I've split up the Bicep wrapper class into several files just to keep track of what's where. So in this build method, I'm basically just imitating what the Bicep CLI does, and this will build a Bicep file, which I will send in here as a Bicep path, and then it will return a build result object that contains the template and some diagnostic results. And then we have a helper method here to actually get those results. And then we have a decompile method, which is, it takes a path to the template that we should decompile, and then it uses this decompile file with modules from the Bicep project. So this thing is a really thin wrapper. It doesn't do much. It doesn't have any real dependency. It's just like a thin wrapper around Bicep. And then we have the PowerShell module, and the PowerShell module has a load context. So here I actually create a module initializer. This code is not mine. I've just borrowed it from a blog post I referred to earlier. And this basically just takes these folders, Bicep and Core I talked about, and it will say every time we load an assembly, we will have an assembly resolver, or whatever you call it, saying that if the assembly we're trying to load is not Bicep.net.core, we'll do nothing. We'll just hand it over to the regular assembly lookup thingy that will find the assembly wherever it finds assemblies, and things will go on as usual. But if we're trying to load Bicep.net.core, we will return a dependency assembly load context for the directory in common path, which is the Bicep folder, and then we'll load it from the assembly name, which is, well, this one. And then we have this load context, which is the thing that we were creating. To be honest, I haven't gone through this too much, but this basically loads all the all the dependency in its own load context. So what this will do is that it will, whenever we call this this Bicep.net DLLs, it will load them into its own assembly load context, and that's like its own little assembly bubble within our process. So this way we can load all the Bicep DLLs in its own little bubble, and then we can't really reach them, but we can talk to this Bicep.net wrapper to reach the backend. I think my camera is froze. funky. See if we can get that restarted. I'll just go back to. Yep. Hang on. Yeah. Just realized. I'll just go back to this one. Nope. Camera, can link, deactivate, activate. Here we go. Sorry for that. Thank you, Jomben. Yeah, so this will load everything in its own little bubble, and then it will use my small Bicep wrapper class to use as an interface that we can communicate with, or like yeah, we can communicate with the Bicep DLLs through this thin wrapper, and that way we can load all our assemblies in its own bubble, and our module will have its own everything, and that will work. So that's kind of cool. And then I just have a bunch of commands. So in this case, I have a build bicep net file command, which is the, well, actually build bicep net file. And as you can, it's super simple. It only calls the bars. So it takes one parameter. This is a commandlet written in C#. Super easy. I use the system management automation, which is the PowerShell, and then I use Bicep Netted Core, which is my wrapper project. And then in the process block of the commandlet, I'll just do like bicep wrapper.build and give it a path, and that will return a result. And then I do write output with the result. Super simple. And then I have the same convert to bicep net, which is the private function we use to decompile, and this makes the same thing, but it uses the bicep wrapper.decompile instead. And then I have a get version, which will just get the bicep version and return that. Super simple. And if I build all this and I copy everything from my BicepNet core folder to the bicep folder, and all the things from BicepNet PS to the core module, and this is where it doesn't really make sense for me. So I'm probably gonna rename this stuff so it's less confusing. So here's my build my build script. It just creates this output folder here, and this folder structure, and then it builds these projects. So for each project it will just write the project name out or the path out, and then it will, if I'm doing running with the full parameter, it will just do build server shutdown, which will make sure .NET is not running anything, and then it will do a clean, and then it will do a publish for each project. And when that's done, it will copy my manifest file, which is this manifest that should be in my PS file over here. So this is just a regular PowerShell manifest saying that this is the thing we're going to use. I don't like the core here. Let's do like module dot core maybe dot net core net 5.0. That makes sense, because the thing is, I can extend this to having like a .NET 5 and .NET Core and full .NET Framework version of this. So I can put them in different folders, and then I can do something like if $, I don't remember the value, but if it's core, like if it's PowerShell 6 or 7, do this thingy, and then I will compile this towards .NET, I don't know, 3 or something, to make it work with PowerShell 6 and stuff. And then I can do like else, and then use the, oh, Sonic, thank you for following, really appreciate it. Then I could be doing this thingy. So I can take this here, whoops. I can take this here, something like this, and set like module.net framework or something. And then I can have the PowerShell module like in 2 different folders, and then I can use the logic for loading, or like side loading, whatever you call it, assemblies for .NET Framework in one and for .NET Core in another, because the method I'm using here for .NET Core only works in .NET Core. So here is the thingy where I have to give it another name. Module.NET Core. Yeah, I think that would be due. That makes sense. Compatible edition is core. What do you say, Bjompen? You usually have good ideas here. Do you think this folder naming makes sense, or should I call it something else? Calling it core is really confusing for me. Just a random GUID or a new unique GUID, and I say I'm just supporting PowerShell 7 so far, and then I export these files. So really simple module. Let's call this module.NET Core, and then we'll go to the script thingy here, and let's say core path module.NET Core. And I wonder, I think I might have had a reference to that in, sorry, this one. Yep. There we go. So I think this should work. And then we have the build script. So we create everything, and then we build all the projects. And once they're built, we copy the manifest to the out path, and then we get all the Bicep.NET Core published files that are either DLLs or PDBs, and then we add their names into our common file. So we create a hash set here containing common files, just to figure out which files are in both these projects. So we're going to copy all this, and then we're going to copy that to the common path, which is the Bicep folder, where we have like files that could be common to other modules, like the AC PowerShell. And then we do the same thing for the PowerShell module, but we only copy files that aren't the same, or like that aren't in the .NET Core folder, and then we copy that to the core path, which is the module.NET Core folder now then. So let's run this and see what happens. Maybe I've broken something. Script/build. Let's cross our fingers. And while that is running, we can look at this thingy and see if we can. So I'm thinking I should commit all this, but we're gonna need a git ignore. We have a git ignore here, but it's not very good, because we're gonna need, so I'm ignoring the out file folder, and I'm also ignoring a TMP folder, either uppercase or lowercase, and I'm ignoring the coverage and test results file, which doesn't exist yet, but I think maybe we'll publish those later on. On top of that, we need a C# git ignore file. So I'm just gonna do like this: C# git ignore. There should be one somewhere. Example git ignore for C# projects. Doesn't like GitHub have official ones? Well, let's have a look at this. $200. Debug releases bin object, nubcake packages, package build, test result, build log, bunch of artifact stuff and cache files and whatnot. Solutions IDE, recycle bin, all Visual Studio stuff. Alright, let's do this. Raw. Copy thingy. Go to here. Paste the thingy. Don't want the space there. Good. So now we have a git ignore. We have a solution file. Let's just see. We have the Bicep core and the Bicep PS projects. And we have the build file. Yep, I'm happy with that. We have a .bicep version. This is the tag we'll check out from the Bicep repository. And we have the TMP folder, where I clone the Bicep file. We have a script, we have dependencies. So this one will take a Bicep version. And if we don't get the Bicep version, we get it from the text file I just showed you, Bicep version. And then we will create a temp directory. And if it contains a Bicep folder, we will remove that, and then we'll clone the Bicep, and then we'll check out the version, and then we will go back to where we were from the beginning. So we have a dependency script, and we have a build script, and we have a run. That I don't want to commit, so that's fine. The out folder should be ignored. We have this types, which I'm actually not using anymore, so I'm thinking we're going to just get rid of this folder. I realize when you do this, there's a lot of juggling with types, because sometimes you have a type available in the bubble and sometimes you don't. And then we're going to have this module loaded as a nested module inside our other module. So we'll have like the regular PowerShell scope, and then we will have like the nested module scope, and inside of that one we will have the bubble scope, and then we'll have like, yeah, it gets a bit complicated, but I think it will work. Right, so I think this is the dev container. This is just a container for a Docker file if you want to run everything in Docker. And we have some Visual Studio configuration. So I don't think we need any of this. I wonder if we did. I think we did. Ignore this. Yep, we did. And then we have the VS Code config with a launch and the tasks. Yeah, that can be there. Fine. So let's look at the build and see if it succeeded or if I broke something. So we build the core, and then we build the Bicep PS, and then we do a lot of copying So now we have a new folder here, and we have the bicep and the module net core and the module manifest here. So if I open up a new PowerShell just to make sure we don't have anything previously loaded, and I'll cd into this folder. Let's make sure. Cool. So now I can do import module out bicep net.ps. Then I can do get module, and we see I have bicep net.ps. It's a binary module, and it has these three functions, and I should be able to lazy build bicep file, bicep net file. There we go. So I can just give it a path and it should work. Awesome. So then I get the result, and that's actually an object. It doesn't really, let's format list, and you can see it has a template, which is the arm template, and since that's an array, it will just put it in extra braces. So, but yeah, and then I have this diagnostic, so I can do like $result dot template, and that's my template, and I can do dot diagnostic, and I get all the diagnostic information saying like this file has on line 6, character 6, it has a warning with the code no unused params, and it says parameter not used is declared but never used. And I added that just to get some output. I hope position 66 is correct though. Let's make sure this, I haven't made a mistake anywhere. Here we go. That is not correct. 1, 2, 3, 4, 5. Okay, so this is probably because it's 0 based. Can that be the case or no? 0, 1? No, then it would be here. Okay, that's annoying. Let's see if I can figure out what we're doing with that one. So the build thingy does here. So for each diagnostic we get back, we create a new diagnostic entry, and we do syntax tree.line starts and diagnostic.span position. So we just get this thingy, and that returns line and char. Okay. So we take that, and then in the commands build bicep, well, we just take that and return it as is. Oh well. And then we had, let's see, in our PowerShell code, source private, right, bicep diagnostic, I think it is. Line and char. So here we add +1 on each of them. Let's do that here too, just to be sure. Because why not? Where were we? Build. So this will return that And yeah, so I think we returned the right thing, like the thing that the Bicep DLLs return, and then we'll handle that in PowerShell. So I have created a new Bicep net diagnostic. Yeah, and we add things here as well. Awesome. Then it should be working. So my plan is to build this, and once it's built, we will package up this out folder as a zip file and publish it as a resource. And then the PowerShell Bicep module can just download that resource and take dependency of that instead of building the whole Bicep thingy. Maybe we can publish it somewhere, but I'm not sure. We'll figure that out. I think we're ready to publish this. Are you here, Stefan? Let's find the... repository I wanted to... Here we go. So clear the screen, make it bigger, and I should be able to do git init. Git status, and we have a bunch of thingies, and we will add the git ignore, git add, that one, and then we will add, well, everything.star actually. I think that should be working. Status. All right, so we added the CS proj, the CS files, the folder profile, whatever that is, publishing profile. I'm sure that's good. The project file for the PowerShell module, and the module manifests, and the commands, and the load context stuff, and the solution. Yep, good. We also need to add the .bicep version. Oops. Add .bicep version. There we go. And we're going to add scripts. I'm not going... Oh, well, let's add a dev container too. And we have a bunch of files with weird line endings. I'm not sure I want to actually do this here. Git config list. I think there is like a config settings for that. I thought there was some. Let's Google that real quick. Git change line ending setting. core.autocrlf. To ensure all line ends repository match your new configuration. Let's bring that in here so we all can see it. Here we go. So what's the setting? Here we go. The Windows depends on the configuration, for example. Yeah. That will make sure everything is Unix style. And here I'll input Okay, let's do AutoCRLF through. I'm uncertain which it should be, but let's see. Okay, let's give it a try. So then we need a bunch of files, git commit message initial commit git reload add origin. Here we go. And we should have code on GitHub. There's a new repository in town. Awesome. So let's try it out and see if it works. Whoops. Can we please move this window? Here we go. So I'll move this out of screen again, and we'll just I think we're here, and we have the cd source ls. So it's this one. Let's just delete that recursively with force. That didn't work because it's probably loaded somewhere. So let's exit out of this, and that shouldn't be using it. This one might be using it. There we go. Just for good measure, I'll make sure I don't have anything more. Awesome. There we go. So now I should be able to create a new PowerShell and do cd. Oh, come on. Cd into here. Awesome. And then we're going to copy from this folder. So copy item out. This one should be copied here. Okay. Now I removed it and then copy it, and it should be there. And we do list that folder recursive. Yep, that should hopefully work. That did work. Awesome. And then we go to the Bicep PowerShell and we look at our module manifests, which is here. Sorry, that was not the manifest. This is the manifest. And let's make sure we have a nested module in here. That's the nested module. And we don't want to expose or export that one because I don't think it exists anymore. So this should be fine. And if we look at the public, we have build bicep, and this one now uses get bicep net version instead of the internal private thingy. And the same is here. This should be using convert to bicep net file. So now when we run bicep build and convert to bicep, we should be using the new version, which means potentially we should be able to not import all these assemblies. I've actually never done this before, so it's really exciting. If we don't import those assemblies, some of our functions, which I haven't fixed yet, will break. But let's see what happens. I'm going to start a new instance or a nested instance of PowerShell just to make it easier to exit out of and unload all the libraries. And then we're going to do import module bicep.psd1. Okay, we get module and we have a build bicep, so we should be able to do build bicep. We build that app settings, we do verbose, and we return the result as string. All right, so now we have the bicep module installed. We have it loaded. We can see it works. We are using this version of the bicep DLLs, and we get this app settings bicep 77, which is the correct position, and we get the warning, and it looks just like bicep exe, and we get the template, and we write nothing to disk, not even a temporary file. That is great. And now we do ac.resources. Come on. I should have a sound effect there. Awesome. So now we actually have the bicep module loaded, and we have the ac.resources module loaded at the same time, and things are just working. This makes me happy. What time is it? 10:30. So I think we have some time to fix the last things. If we close down this one, and so we don't need that one anymore, and then we need convert to JSON. convert this into Bicep. This one. Okay, so this one is using the Bicep types directly, and those are not available anymore. We can't do that. So let's see what we're doing with them. We're creating a file resolve, a resource provider. We get a temporary path, so this things should not be there. And this is where we do the decompile file with modules. So this thing has to be rewritten to something similar to this. So we can probably just take this one and say Bicep object equals this. Remove that line. And then, if I remember correctly, we don't have any items. So we just do Bicep object.keys. That should be the same thing here. So we remove, oops. Let's remove that part. Whoop. And then we do Bicep data equals Bicep object index Bicep file. Yeah. I think the same thing goes here. Bicep file. Yep. And then we do some replace, and if we go to clipboard, we do Bicep output. And then, yeah, I think that should be working. Exciting times. What was the other ones I had figured out? New Bicep parameter file. Oh yeah. This is going to cause a conflict, but we'll have to solve that later on. So this thingy creates... this gets the assembly location and the version from that. And we do that in build Bicep, I think. So we can just do this instead. New Bicep parameter file. This whole thing can be this instead. And I finally get to fix this space. And I don't think we have any other Bicep DLL dependencies in this file, so we're good. And then we have the test Bicep file. And the test Bicep file takes a diagnostic level. So I think I created a new class for this. Ta-da. So we can actually, where are we? Test Bicep file. We could do this instead. And then we'll see if this is this. We'll do that. And that can be replaced with this. And this can be replaced by this. And we're not using anything else. And then we do the level. And that should be able to use this instead. It's so quiet. So do you mean that I'm quiet or that everyone is quiet? Yeah, no, everyone is quiet. No one is in a chat mood today. But I'm in a good mood, so I'll just keep going. But apparently you hear me, so that's good enough. Or like at least. Oh, thank you for the stream. I had a great time. What was it, yesterday? So much. So if you haven't listened to DJ Reeser, he plays awesome music. I don't have this. He has this cool shout out thingy. I don't think I have that. I did some bot things, but I don't think I have a shout out command. Let's try it. DJ Reeser. No. Stream elements. Yeah, that's the one I'm using, but yeah, I think I have to work on that. Yeah. Sometime I did write my own smiley though. I'm not sure if that works. Have you seen? I have a PowerPoint smiley with my awesome image editing skills. Yeah. Anyway, here we are. We are replacing the bicep diagnostic level, and I think that is it. Let's check my notes. Yeah, those should be everyone. So let's do a quick search and find for bracket bicep. And core.ps1. I wonder what that is. Yeah, so that's just my me experimenting. We have a readme, we don't care about that one. This one is okay. Parse bicep, that's not gonna work. Okay, so in this new version, this file will not work. And we need to make sure that we don't use that anywhere. Okay, and then we have the right bicep diagnostic. That's not gonna work either. We're gonna make sure it doesn't work. Yeah, thanks for calling it nice emote. That's about as far as my image editing skills goes. It's 2 circles and 2 characters. This thing should be working, and we should use this instead of that, so that should be fine. Convert JSON to bicep. These thingies commented out. Let's remove this. Who likes comments? Yeah, that's how we should do it. And let's remove that line as well. And then we have these lines. Let's remove them. Let's call it the big purge. And then we have a bunch of argument completers there, and those are not using bicep types, so they're fine. We have a commented line in there. Let's remove that one. And then there's an argument completer. That's fine. And that's my new thingy. That should be working. All right. So now we might need to make sure that we're not using parse bicep. That won't work. And that won't work, and that won't work. So let's close everything because I'm getting confused by all this. We built that one, and I think we have built Bicep. I more or less sold this. So in here we have parse Bicep net. Build result, build Bicep net file. So this will give us build result, and the ARM template is basically just the first template there. So we can take that part. And we can take this part and replace it. And we're going to use the first one. That should be working. So what are we doing here? We are getting an item from path. What is the path? The path is the Bicep file. So we're just calling parse Bicep. Yeah, this one will have to go. So I'll actually have to rewrite this whole thingy, I think, which kinda is boring, and I'm too tired to do that right now. Let's save something. I'm going to do comment here saying this won't work. Bicep net has to be rewritten. There we go. And then let's just make sure. So parse Bicep. There should be a begin saying right warning. This parse Bicep does not work anymore. I'm sorry. And then we're used to something break return. Yeah, that will just break anything trying to use this. And we had something else. We had the right bicep diagnostic. Right bicep diagnostic. Just copy this thing. Here we go. Right diagnostic. So I don't intend to keep this here. I'm just making sure that I'll find anything or any place I use this, because if we try to do this, it's gonna just barf a whole lot of problems. So this is just a nicer way to say that we hit a problem. So I think this should be enough. I think this should work. Let's go here. We have the module. Let's exit out of this and create a new PowerShell instance. Import my new Bicep file. Get command module Bicep. Working good. Build Bicep. That works. We don't import the thingies. Then we should be able to do this. I don't think this is apparent, but I'm so impressed by this. It's mind-boggling. I don't even know how to... So this should probably not be committed because it's a bunch of binary files. So we probably don't want that in our Git repository. Copy relative path and go to git ignore and you say ignore this, please. We're using slash everyone, so let's do it here too. Slash. All right. I'm happy. I'm going to commit this and I'm going to do like a draft PR for it. And then my lovely friends can have a look at it. We're gonna need to add all these and that one and that one. And this is just random garbage. Like I said earlier today, my code isn't as neat as I would like it, but yeah, I guess that's life. I always end up with all of these untracked weird files everywhere where I spread my notes and do like weird tests and whatnot. What's the difference between VM versus container and Docker stuff? So I'm sorry, but I think that's a little bit too far from what we're doing here. But the really quick answer is like a virtual machine. It's a virtualized hardware. So you have a virtual computer. And on that computer, you install an operating system and you run your applications. A container is a virtualized operating system. So instead of having like virtual hardware on your computer, on which hardware you can install operating systems, you create virtual operating systems on your computer. And in those virtual operating systems, which is a container, you can install applications. And the upside of that is that the containers are a lot smaller because they don't contain an operating system. They will share the operating system with your computer, which makes them smaller and faster and really nice to work with. The downside is that they are sharing operating system with your computer. So if you're running Windows on your computer, you can only run Windows containers. And if you run Linux on your computer, you can only run Linux containers. And the Linux containers will run the same Linux version as you are running. But that's a true, like, half truth, because in Windows we now actually have Linux and Windows. So if you run Windows 10 and use WSL, Windows Subsystem for Linux version 2, you're actually running a full Linux kernel side by side with the Windows kernel. So if you're running Windows 10 today, you can actually run Linux at the same time. And then you can run Windows containers on Windows and Linux containers on Linux, which is really handy. So I really recommend checking out containers because it's I use them for like developer, like if I wanted a clean developer environment, I can spin up a container and develop inside of that container. That's the super short answer to the difference between containers and virtual machines. Yeah, if you want to know more, I recommend you to check out docker.com or whatever. I think they have a lot of good information on how to work with them. Thank you. So let's see if we have all the... Yep, this should be it. First draft for using bicep net.ps instead. Just loading instead of loading bicep TLS. Yeah, that'll be fine. Let's see if we can get it under 50 chars. Draft for using yeah, that's good. Oh, thank you for following us. Husamadil. Sorry, I'm slaughtering your name probably. But welcome to the channel. I hope you enjoy it. This is draft to make this work. We need to copy bicepnet.ps folder into resources folder. Bicepnet.ps can be found at psbicep/bicepnet, I think it was called. Where is my GitHub thingy pagey? psbicep/bicepnet. Run scripts slash build .ps1 to generate to build the module into out folder and copy to this project. To do fix. There's going to be an extremely long message, but I hope it'll help me remember what I'm fix test bicep file. Maybe we should have like this probably. We need to fix the bicep file. We need to set up scripts to download bicep net.ps, and we need to create workflow to publish bicep net.ps as release or something. I think that's everything. I really hope so, because it's getting quite late and I'm getting quite tired. Right, looking good. Let's push this to origin. And won't really be able to merge this because there will be a bunch of conflicts and a general pain, but I'll open up a draft PR just so we can have everyone look at it and do not merge like this, and it can merge because there is conflicts. And we want to label, it's probably an enhancement, maybe. Create draft. draft here for using Bicep. And then we should probably copy the, where were my terminal? Here we go. Git log, whoops, 1. Let's just copy this. Good enough. And that's one. Yeah. There's the conflicts I was talking about. We have to fix that. But we'll do that later. At least we have a start for breaking out the DLLs and run them in an isolated bubble. I'm really excited for this. I think it's super cool that it's possible, and I still haven't really grasped how it works. But thank you for hanging out with me. I hope I'll be back here next Monday, if not earlier. And until then, take care and see you another week. Bye bye.